All right, welcome. In this video, I want to continue talking about column types in the readr package. So the readr package is one of the core tidyverse packages that is super useful for importing data stored externally in a file. So for example, we've been importing CSV file into R using the read_CSV function. So in total, there are 9 different column types to use. So we've been talking about what are the column types and how we can override them in the import, and what's the heuristic that is used to determine which column type is assigned to different columns in our original data. So the possible column types that are available are logical, double, integer, character, factor, date, date, time, number, and skip. We'll kind of talk about some of these. So we've seen some of them. So the only column types that can be assigned using the default algorithm are logical, double, date, and character. So typically, you don't normally need to specify those inside of the read functions because it does a pretty good job of guessing those correctly. It is never going to format something as an integer, so you will have to override that if you want your column to be read as integers. Yeah, and so what might seem odd is this column skip. This is actually a column type. It means don't import this column into R. So this is helpful when you have like a really large data frame. You can save a lot, and you only want to import a couple of columns. You can save yourself a whole bunch of time by skipping certain columns in the import step. So here is a data frame that we can create from a CSV file, which is stored online. So here's this student's data frame that we've now imported into R. And take a look at the column types that have been chosen here. If I want to, we've talked about how we can override the column types. I would just say col underscore types, that's the argument name, equals, and then inside of a list, I define the column types using the syntax column name is equal to column type. So here I haven't cleaned up this student's data has other issues, but let's say when I do my import, I just want to import the student ID, their full name, their meal plan, and I don't care about their favorite food, and I don't care how old they are. Then I can list the column type as skip, and that means it's going to ignore those columns when we do the import. So I'll run this command, and you can verify here that, in fact, we did not import favorite food, and we did not import age. So that's actually a column type to ignore them, and now they're not in the data frame that was created. But I would kind of define those inside of the call types argument, just like we did earlier. And one thing that is also nice is sometimes you might want to, by default, set all of your columns to the same data type. So for whatever reason, let's say I want to take this data frame, or excuse me, this CSV file, and when I import it, I want everything to be double. I want everything to be read in as double. So it's going to read full name, favorite food, meal plan, and age, all as double, all as decimals. Rather than have to list every single one. So rather than have to say student ID equals call W, full name equals call W, I can save myself some time by saying I want the columns default to be equal to double. So that's the syntax that I would use for that. It's call types equals calls, and then inside of parentheses, dot default equals call underscore double. So we can run this, and every column is now a double. That's great. But since most of the information in our data is character strings, anything which is not a number, it's going to be replaced and treated as a missing value. So this whole full name column is going to be a bunch of NAs, favorite food, bunch of NAs, meal plan, bunch of NAs, age is going to convert the character string 5 to an NA, and that's what happened over here. And we have a warning message again because it did a bunch of transformations. It replaced a bunch of text with NA. And here would be a case where you would look at this and be concerned, right? And you would probably want to know, was all of this stuff really missing, or was there a data entry problem in what was originally there? And looking at problems will help you identify what data was originally there before it got replaced with N8s. Okay, so that's a break for this video. We will continue on this module in the next one. Thanks.